Hello, we're back again. We've got a bit of a diversion going on here. The intercom, ESP32 Video Intercom, on hold for a bit. No reason other than I need to create myself a carousel, a SMD component carousel. So I spent today designing this. I've got to split it all up over the next, probably tonight, hopefully. And once I split it all up, I can put my components in it ready for building. I'll just give you a run through it. It's quite interesting. If anyone shows any interest, I will. I'll put the G code out there so you can make your own. You know, rather than just a design file, I'll put the G code. So let's give you a little run through it then. Okay, so basically I've got a couple of pieces of 12mm acrylic left over. Well, it's just surplus. I'll show you. Yeah, that's it there. Bit of acrylic. It's 12mm thick. So I've got two lengths of that. I've got enough of that to make the one. I've got enough to make one complete unit. So let's give you a run through it. It's not black and white. It's semi-transparent. So this design is semi-transparent. Let's run you through it. I was inspired from this by Unexpected Maker. He 3D printed one. And I thought, on a live stream, I asked him, I said, where do I get them? You know, where can I buy one? Where can you buy one? Apparently, you can't buy one. There's some design files around, but then I couldn't get hold of them, or I didn't want to 3D print it anyway. So I wanted to route it, CNC route it. And I thought, well, if I'm going to design one, let's have a good one. Let's see what we can do with it. Right, let's just show you what it is. Right, imagine there's 3 bits of 12mm plastic here. So you got your base, and you got your selector row. Originally, it was only going to be one selector, a base, and then a cover, basically 2 pieces. Well, it was going to be the middle one. Then I ended up putting a base on it. I thought, well, if I have a base, I might as well have another row to put stuff in. Let's take this apart. So I'm just going to back off with the so we've got the rubber mat, the top cover, which is 5mm. I'll leave the spacers in. The assembler. What I call it is the top one. It's not really the assembler anymore because I renamed that. Then I got one I call the selector. It's not the selector because these were named from when there was just one. Right, I tell you what, let's cut some of this off. I'll put it in an order that you can see it. Okay, let's get rid of the dowel and the bearing. So this is going to be the base, right? And so it's a 12mm piece of plastic. I've designed it to fit these bearings here. I'll show you the bearing. Alright, I went on eBay and that's not the right one. Bearing, there it is. And I found this bearing quite cheap on eBay. There's no weight to this, so it's not gonna be under any pressure like what this bearing should be. But this is a 35mm OD by 15 ID, so, and it's 11mm thick. So I had to design it around something that I could get hold of quickly, or anyone could get hold of, not some obscure one that I just happen to have lying around that we can never find the size again. Anyway, so I did that. And this first bit, so what you've got 24 pockets minus the 1, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 3. So there's 23 sockets. There was 24 in the bottom. I've lost it. I got rid of it. Because what I wanted to do is, when you line this up, you can put a clip through it. I'll show you that in a minute. Anyway, these two locators here, these things here, this is so the registration marks, or I suppose it was a circuit board. You could call it fiducial, but it's when I CNC it, these will be the first holes that gets CNC'd in the plastic, and it's so I can turn it over. Now on this one, does not necessarily to turn it over. It's difficult to see when it's all one colour. Well, it's just transparent. But if I was to just double click on it and then show you that, see, this is all one colour. Tell you what I'll do, I'll colour it. I'll colour it in, how should we colour it in red? Yeah, let's colour it in red. So, I'll undo that in a minute, but you can, is that a bit bright? Hang on, that's a bit bright for you. Let's get some pale colour. Right, that's horrible. That's it for me. Right, you could spend hours choosing the right colour. Anyway, so that's just to show you that there's no milling on the bottom, because these dowels go straight through from the top, so there's no need to mill on this one. Anyway, so I'm going to undo that, undo the paint, and I'll come out. So that's back to as it was now. Oh, no it isn't. Oh god, hang on. Let me get it back, so I don't want to mess it up. That's because I painted it so many times, different colours. Right, anyway. So how are we doing? Let me just, I presume I'm streaming, but if it doesn't, it doesn't. So it's not going to be a long video, this one. Right. So anyway, we're back to the top. So you got these registration holes that I can fix. I'll have a spoil board. I'll have some holes in it. I might even mill out something in metal, just to keep these, so I can screw basically M6 machine screw this down. And if I do want to mill the back, I can flip it over, and it won't have lost its position. Anyway, so you got these pockets here. It's probably not the best colour, this transparent, to show you anything. Anyway, so these, they're not that big. Let's have a look. Let's measure them. So we've got 28.9 long, 11.7 millimeters at the back, and 19.26, and we got 10 mil deep. So 10 mil deep, 12 mil plastic. So it gives you a couple of mil of clearance at the bottom, just for the backing, you know, just the bottom. Should be fine, 2 mil. Anyway, so there's a little space in there. So, right, so back to this bit. So, once I did that, I need to connect the bottom piece. That's the bearing slides in here, and there's about only half a mil. I think it's half a mil. Let's go, yeah, half a mil clearance. Anyway, there's a bit of clearance, so you push the bearing in, and the 12 mil plastic, so 11 mil thickness on the bearing, so I can push it in, and if you can see, it's just 0.25 of a mil sunk in. There's a reason for that. There's a reason for everything. Anyway, so I can have next thing you'll have between this and the next one. I'll just explain what these are. Before we go on to the next one, let me put some bearings in. Ball bearing, bottom. Right. So I kept on evolving. I was just going to have it spinning, but I thought, well, it might just spin around or not hold in position. If you had to carry it, you don't really want it spinning. If they spin around, then all the components drop out. So what I did is I put, it took me a bit to get this sphere to make in SketchUp. Anyway, got it done. I was trying to make a sphere that was too small, it wouldn't do it. So I had to make it bigger, then scale it. That was the answer. Anyway, so I thought I've ordered a pack of 20. They're 4mm bearings. Okay. Now I've drilled a 4mm a hole, and I sank it at 1.5 mm. Probably too much, really, 1.5 mm. But I'm gonna alter the spring so it's very light. I'll show you the spring in a minute. Let's show the spring there. Why not? There you go. So we've got these springs. Am I in perspective? Yeah. Right. So these springs, they're only going to be light springs. And basically, it's like a selector switch. So when I push this that way, the ball is going to have to ride up over the plastic, and it'll click back in again. So when I spin it, I'm going to have like a click, 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 and it'll, because these are the same on the other piece. Let me get you the other piece on. Selector, I call it. So they've got this selector. This is the way you start losing. This selector has got, actually, let's not put that on. Yeah, so you drop your spring, you build it, you put your ball bearings in, you drop your spring in down there. Okay, then you put your top ball bearings on. Okay, so the one hole, you save basically 4 springs this way. See, I've never seen this, but maybe it does exist, but I've just designed it. So your ball bearing down there, ball bearing up there, a light spring. This is a 3mm spring. I've ordered, I think I've ordered 2 at 45mm long or something like that. And they only need to be about 10mm. So I should be able to cut them, I suppose, if I need to cut them. I'll just probably cut a few in half. This will have to be altered. It might be too powerful. I'll have to stretch the spin, you know, unless I buy a kit of springs. But I bought what I think will do the trick job. It might be too powerful with the size of this pocket and the spring tension, but I can always cut the spring, stretch it a little bit, weaken it, and when I end up with the ideal value for spring, excuse me, I can just order. I can just, you know, try and locate some springs like that. But I mean, anyway, so that's that bit. So as you can see on here, you've got another row exactly the same, another 23 bays. What I was going to do is stick a label, a white label on here, or I could even make a stencil, laser cut a stencil of paper or card, the exact same thing. So it cuts it all out and it just sits there. But at the minute, I mean, you could write on it with a pen. It's plastic, you could wash it off. Or you could put a little square sticky label and write on what it is. Or you could drop the label in the box and just put your bits on top. So the bag it came out of with the part number is just facing up anyway. There's lots of different ways of doing it. I even thought about milling this out and putting LEDs in it here so it light it all up. But I thought, nah, going crazy now, going a bit over the top, and then I'd have to put a battery in, then I'd have to put a microcontroller in. And I thought you could select it, you know, get the computer to select the part, choose it on LCD display or voice command. I thought, nah, let's just keep it simple. Can't do it all in. Can't do it. It's just wild. Like, but this is designed just as a mechanical. We'll stop the feature creep now. We'll just keep it as we got it. So that bottom bearing, hang on, I haven't showed you the, let me just go back a step. Let's take off the selector. Now in here, the bearing is just sat 0.25 of a mil below the surface. Alright, and I've put in a spacer. That's not it. Where's my spacer? Bottom spacer. Right, now this is a little bit of a spacer. Slightly bigger than 15 mil, but not big enough that it goes across the middle bearing sleeve, or whatever they call that, and the outer bit. So that'll basically allow the two surfaces. If I put on the selector, you can see, you can't hardly see it, but might be better if I go into X-ray mode. No, it's got. Anyway, you can see it. Let's go back out of X-ray mode. Right, so let's. I'll tell you what. I'll go on to parallel projection. Okay, so you can see it from here a bit better. So that's the back of the plastic for the bottom. The bearing slips into there, and I've allowed a 0.25 of a mil clearance. So you can push the bearing to where you want it, and the same at the top. And the spacer is just this bit here. If you can get it, can I get it? Can't get it. Oh, you can get it. Yeah, it's there, but it's not showing it. So there's your spacer, and what that'll do, that sits inside 0.25 of a mil. It's only half a mil thick, this spacer, and it sits flush with the bottom of the selector plastic, or this top plastic here. Okay, so it sits on it. The reason I made it sit on it instead of embedding it in there, because depends which way you're putting your bearings in. So I've pushed this bearing in from the top, which allows it to sit down, and I can put that washer or spacer on top of there. Or it could even be a shim yet. What I'll probably do is, if it needs a very thin piece, I might just roll out some Coca-Cola tins and CNC the Coca-Cola tin, flatten it out. Might need 2 or 3 shims off that. I don't know. You certainly can't get a washer this thin, half a mil thick. Might be able to. Anyway, it might need some. I'll probably just make a load of them out of Coca-Cola shims, and just put as many as it needs to make this gap. This gap bit here is it's only tiny. I don't want a gap, but I don't want any friction either. So we've got 0.25 of a mil, so 1/4 of a millimeter space. Hopefully no components can fall out of there, but I want to reduce this down, so the shim side of it, the shim there, depends what it's going to be. It could be 2 or 3 pieces of shim steel or Coca-Cola tin, anything, or or I might even mill it out of some aluminium, very thin aluminium. Anyway, so there's that. Right, next thing, let's go back onto parallel projection. Okay, so we've got 2 tiers. And you've got your ball bearings there. So what I'll do now is I'll put on now this bit here. Yeah, I'll put another spacer, middle spacer. Now this spacer here, same again, but Coca-Cola tin, very thin piece of steel, exactly the same as the one down there. And this just sits on top, flush. Let's go back to that one. Get rid of the parallel projection. As you can see, it's flush. It's flush with the top of there. This one sits slightly in on top of the bearing. This one's flush, so it sticks up above the surface. Okay. Right. Now the next one obviously it's got to have the patterns again, the same patterns for these ball bearings to snap into. So what you're going to be able to do, you're going to spin this one and it'll snap. Or you can spin the two at once if you want. Obviously that's on the table, so you've got to put, that's your base which sits on your bench, that bit there. So that's not really going to spin, but you could spin it if you want to. You basically put your hands on the round thing, hold the top two, and then spin with your finger the bottom one, and just put it back on the desk again. Or, you know, I'm trying to keep it stable. It's got to be strong, and I don't want to introduce anything here like a small space. Then I don't want it to wobble like that. So I'm sure we could manage that. I say it's trial anyway. Anyway, so there's that. Let's go back to perspective, right? So we've got that one there, and then we got what I call the assembler, but it was the assembler because I wasn't going to have a lid. I was just going to have this bit on top, and this bit wasn't going to have any pockets. Just going to be literally a lid. And I thought, that's a waste of plastic, really. I mean, I could have a load more. So, anyway, I did the same again, and these double-ended spring ball bearings can snap into the top, so you're able to click the bottom, click the middle, and click the top. I don't know what it'll be like in real life. If it's too powerful, I'll reduce the springs, or I might even have to take some of the balls out, just leave the one in. I want to the 4 in so it holds it even, so it doesn't start doing this business. Anyway, right, so there's that. So that's the top one, and you need another spacer because obviously all these holes, all your bits will fall out here. So they've got a 5mm piece of clear polycarbonate or acrylic, doesn't matter which. Probably polycarbonate would be better, or stand a few more scratches and whatever. So anyway, but before I put that on, I need my spacer, so I put another spacer on again. It's like a multi-layered thing, this. And your registrations are all lining up still, so if you look through there, hang on, it's hard to see, but you can see straight through it. Now, again, this is for the CNC table, so I can flip it over and mill both sides if need be. Right, so to finish it off, we have what I call the cover. Oh no, let's put the bearing in. There's the top bearing. Right, so there's another bearing in there, but instead of it coming in like the bottom one, I can't even see the bottom one now. Let's go around a bit to get to the, hang on. Is it making you seasick? Yeah. Instead of it coming in from, on this bottom one from the top, this one comes in from underneath. Okay. And that's so, just so all these washers can line up and sit on top. Don't know if it's going to work. I've no idea until I build it. Possibly it'll work. I'll try to envisage it, visualize it as much as I can. But at the end of the day, sometimes you just got to build one and see. You could sit there pondering for weeks trying to work out whether everything's in the right place and whether even the design will work. So anyway, so that's that final space. So then you've got your cover. Okay. Now the cover is a 5mm piece of polycarbonate or acrylic, same shape again. Now this time it's got no, because you want it to seal these. Each one of this, each preceding one. No, what's the opposite of preceding? I forgot now. Anyway, each additional one that you layer on top seals the one below, and so forth. But obviously you've got to stop somewhere, so possibly with this design it could be made to go taller and taller. But you've got to work out, you don't want too high off your desk, so at the minute what we got here. Let's measure that to the top of there. 39.75. So I've got less than 40 mil. So it's only about that much. About 40 mil. So I can cope with that. I like the idea of that. That's not too high. Right, so let's have a look at this this bit here. So again, we've got the registrations or the fiducial things to line it all up. They all line up again. For transportation, I could even make a carry handle that sits in there. You can make a carry handle that plugs in with some like clips that clip over like a circlip. Anyway, so there is that. Right, so not finished yet. So what we've got now is a dowel to connect all this together. You haven't seen, obviously something needs to line up to keep all these together. So what we've got, I've called it a dowel, but it's probably a piece of bright bar or something. It's 15 mil ID. If I remember right, copper plumbing is 15 mil. It could be a piece of copper. Bright bar is a bit heavy if you had to cut a piece of 15 mil bright bar. Or it could even be wood, but I've made it out of steel. Okay, so that's that. And what I haven't done is that actually comes out of there, doesn't it? Yeah, hang on. Yeah. So the cover sits on the dowel, basically. Can't see it from here. Well, the dowel comes out the top of the cover. And you see I've got this recess here. It's not much of a recess. 1.45 mil. Yeah. It's a little bit of a recess. Now I'm going to use a rubber mat. There's your rubber mat. So your rubber mat will cover all this area here, and this is your build mat. So you basically get your circuit board. You could have it that way, facing like that. You have your circuit board on here. Now it'll take a circuit board of 116 mil. Yeah, it's about 116 mil. So you should be able to get a 100 by 100 circuit board on here. And the rubber will hold it still. So you can solder it up. Well, solder it, pick and place it. And again, a bit of inspiration from Unexpected Makers one. I did this not a few minutes ago. Basically, because we're not doing anything here anymore, we've got no holes here. We've got a bit of spare space, so we can pick out the components you want. Tell you what, have I got everything showing? Yeah. Ah, you can't see it because I haven't spun them around. Yeah, so when you spin around, you'll bring the bays out as you need them. Right, so this is a little bit of a recess. It's not very big. So, hang on. Let's go from there. So it's 6 mil wide, and it's only 2 mil deep. It's in a bit of 5 mil plastic. Now all that'll do is you'll be able to drop all your stuff you're working on if you want to. You know, you can fetch your stuff out, you can put it around here, drop your little components in here, resistors, SMD stuff, anything, chips, whatever. Just rest them in there, stop them flying off. Or you can just leave them in there. So anyway, so yeah, I've got to make this. I've got to split all this up into a G code. Take each tier and generate the G code from it. And this, I was going to have this bottom piece so it's all the way around, but I thought, well, leave it like that. So when they're all lined up, if you want to carry it or transport it, you could devise some kind of a bungee or a small elasticated band of some sort. Just put it around there. Put it around there, and it'll hold, stop them spinning. But it won't spin because of the ball bearings anyway. But if you want to be doubly safe, so potentially you could put another tier on this. You could take the mat off and that, and you could extend this up. You could just, let's just do one quickly. Let's go up by 12 mil. Yeah. So I'm not going to do this, but it's going to make it too high. But you could have another tier if you want. But you'd have to alter all your bearing stuff. So you'd really have to play around with your bearing. So I don't need all that money anyway. So anyway, it's just an idea. It could be. Alright, so okay. Anyway, so that's half an hour. You can see what I'm doing. So I will build one of these. Might not be today. It might be tomorrow now. Because I've got to sort all the G code out. And I'm waiting for the bearings to come through anyway. So, let's take the top off. Hang on, assembler. I'll take the middle. Let's take the selector out, the middle. Right, so in here, you can see the springs. What they're doing. So, I don't know if it'll work. I have no idea. But it looks like it might work. If it doesn't work, I've spent about £7 on bearings and stuff. Plastic I already had. I'll have to find a bit of rubber mat. I only want some thin stuff. Might have to make that out of foam or something for now. But anyway. So, anyway, that is the SMD. Let's bring it all back again. Make sure we got it all. Yeah, that's your SketchUp model of an SMD, surface mount device, or SMT if you want to call it SMT, where you can store it and build. So you get your stencil out, do your paste your board, drop your board on here, and then just assemble it. Once you've assembled it, take it over to the oven, reflow oven, just reflow the solder, and that's it. I mean, you could have multiple of these. You could have one for each project, but most of my projects are going to be built with this similar items anyway. A bit like a menu or ingredients for a cake. You use basically the same stuff for each circuit board. All right. So anyway, I've been David from UPass. If you're interested in one of these, or you want the design files, enough people ask, I'll make it available. Alright, and I shall catch you on the next video, which will be probably my CNC milling it all out. And I'll show you the physical thing. We'll see if it's any good. Worth a go, eh? Now, I'll just let you know, I haven't looked at any other designs. I haven't even looked in detail at the one Uninspected Makers made. I watched him use it once in a video and liked it, but let's see what it looks like. It'll look weird anyway. It'll be a weird thing, won't it? So, if you did a 3D print, now if you 3D printed this, would it even work? Yeah, you can 3D print it. You can't laser cut it. You wouldn't be able to laser cut the pockets, I don't think. So you'd have to make it as sandwiches. You'd have to literally cut these pockets or draw things right through, and then you'll have to layer it. I've got a laser. But there's certain things you can do with a CNC that it's a bit difficult to do in one piece with a laser, I think. Correct me if I'm wrong, but the result from a laser is better quality. You don't have to do any deburring, so I'm going to have to go around this. I could generate G-code with a bevel just to finish these things off, because I can tip them over due to those registration marks. These, you can put a rod straight through it. I can fasten it still, each one in the right place, and I could just get the computer to mill around it. But I'll probably, for this one, I'll just sand it lightly sand it all the way on that edge and the bottom edge. So when it's in your hand, or if you're resting your hands over it, if you're resting your hands while you're building it, it's not going to put a horrible line on your hand. Anyway, let's see how it goes. Right, I'll let that one go at that. So it's Dave at UPass with the SMD Carousel design in SketchUp. Gonna have to do the G code for it, split it up and make G code and set it in motion. Alright, well, thanks for watching. Hopefully I didn't bore you too much. Catch you again on the next one. Bye bye.